Hello everyone, myself is Vanaja, working as assistant professor in Siddhartha Institute of Technology, Puttur. Today I am going to give video lecture on flag registers of 8086 processor. As in previous video, we already see what is the architecture of 8086 processor. In this execution unit, flag registers plays vital role. Now see what is the basic principle of this flag registers. So this flag registers of 8086 is basically a flip-flop. It is a 16-bit wide with a collection of 1-bit values that indicate the current state of the execution of arithmetic and logical instructions in the 8086 processor. Out of the 16 bits, 9 bits are used in the 8086 as shown in the below figure. In this 9 flags, again divided into two groups, namely status flags and control flags. Here, the U represents unused or undefined flags. Out of the 16 bits, only 6 are undefinable, remaining 9 flags are definable. So, under this 9, this carry, parity, auxiliary, zero, sign, and overflow flag comes under status flags. Remain, direction, interrupt, and trap flags comes under status flag. Now it's a clear vision about this status and control flag. Status flags also known as conditional flags. This conditional flags or status flags are of 6 types. Those are all carry, parity, auxiliary, zero, sign, and overflow. And control flags are of types, 3 types. Those are trap flag, interrupt flag, and direction flag. Now we will see one by one. First comes under status flags. As already seen in the picture, it is of 6 types. First one is carry flag. Carry flag means whenever we are doing the binary addition, if there is a carry exists, then it will be set to 0. If there is no carry, it will be reset. That means it is set, that means 1 when the carry occurs, otherwise it will be reset. That means carry flag is 0. Next flag is parity flag. So parity is related to the number of ones contained in the binary data. This parity is of 2 types. One is even parity and another one is odd parity. When the number of ones in the binary data are even, then it is known as even parity. If it is in an odd number, then it is known as odd parity. For the parity flag set, if there exists a even parity, the data after the execution of the instruction, else the flag is reset. That means if in the result, binary addition result, the number of ones is 1, then the parity is set to 1. Otherwise, the parity is 0. Next, third flag is auxiliary carry flag. This flag is set if there is a generation of carrying from a nibble, that is the 4 bits of data. Next flag is zero flag. When this flag is set to be 1 means the result is 0. Otherwise, it is set to be 1. That means the result after performing the required operation on the instruction is 0. Then that case 0 flags are set. Otherwise, it remains reset. Then next flag is sign flag. If the result after performing any arithmetic or logical operations in the given instruction is a negative, then the flag is set to be 1. Otherwise, it will be 0. That means reset. And last flag in status flags are overflow flag. This flag will be set if the register gets overflow with data after any ALE operation. That means in case when the carry is getting in the MSB bit, but there is no space in the register to store that extra bit. That means overflow. So when overflow occurs, then the flag is going to be set. Otherwise, it will be reset. This is about status flags. Now we will see the example for the status flag. If you take one addition, that means 0, 6 and 54, which is in hexadecimal. If you are performing the binary addition operation, that means 0 plus 0, 0, 1 plus 0, 1, 1 plus 1, we are getting the carry 1 and result as 0 and 0, 1, 1 and 0, 1, 1, 0, 0, 0 and 0 plus 1, 1, again 0 plus 0, 0. That means here we don't get any carry. That's why carry flag 0, 0. And the result is not a 0. That's why 0 flag set to be reset. That means 0. And from nibble, fourth bit, there is no 1. That's why auxiliary carry flag is 0. There is the most significant bit, that is MSB bit is set to 0. That means sign flag is also 0. And count the number of ones in the result. That means 1, 2, 3, 4. So this is a even number of ones. That's why parity flag is 1. And there is no extra bit in the results. That's why the over flag is set to be 0. So from this example, it is very clear that the carry flag is 0 and sign flag is to be 0. And auxiliary flag 0, parity flag 1, 0 flag 0, and over flag 0. Now we have to see the control flags. What is the main functionality of this control flag? Depending upon the value of controlling the flag bit, the processor will control a particular operation. That is, these flags are used to control a certain operation. There are 3 controlling flags, namely interrupt flag, direction flag, and trap flag. Now we have to see what is the individual functionality of these flags. First, we will see the interrupt flag. This is the interrupt flag. If interrupt flag is 1, then the microprocessor will recognize the interrupt from the peripherals. For I is equals to 0, the interrupts will be ignored. Then direction flag. This is used to string related operations. That means if it is 1, that means set, then the string will be accessed from higher memory address to the lower memory address. And if it is reset, that means 0, it will do reverse operation. And finally, the last flag, trap flag. This trap flag is used for on-chip debugging. When t is equals to 1, it will work in a single step mode. After each instruction, one interrupter is generated. It helps to execute some program instruction by instruction. This is about control flags. So, if you are seeing the overall action of our flags, out of the 16 flags, we have only 9 definable flags. The first one is carry flag. When it is set to be 1 means if the MSB bit is 1, then it is set to 1. Otherwise, no. Otherwise, it will be 0. And parity flag. If the result is having even number of ones, then it is set to be 1. Otherwise, it is 0. Then auxiliary carry flag. Carry from lower nibble to higher nibble. Then it is set to be 1. Otherwise, it is in a reset condition. And 0 flag. If the result is 0, then it's set to be 1. Otherwise, it is reset. And sign flag. The most significant bit is 1. That means it represents negative number. Then it is set to be 1. Otherwise, it is 0. That represents it is a positive number. Then coming to overflow flag. When overflow occurs, then it is set to be 0. If there is no overflow, it will be in reset condition. These are 6 flags comes under status flags. Now coming to the control flags. The first one is direction flag, which is 1 when auto decrement is happen, and which is said to be 0 when auto increment is happen in the string instructions. For interrupt flag, when the interrupt is enabled, then it is said to be 1, and disable, it will be reset. And finally, trap flag. If it is 1, It's performing single stepping operation. Otherwise, it don't perform single stepping operation. This is the overall function of our flag register. Thank you.